let's try this 10-mark headbanger, maybe. So what we have here is a very long 10-mark question of differential equation. Oh, wow. How am I going to deal with this? How will I even deal with this? Yeah, before I would answer this question actually got me a little bit over there just to understand what I had to deal with. Now, obviously, as an A-level candidate, I would have to face this sort of scenario at least once in a while. And this was one of the questions in which I had to deal. So, because it had combined differential equation and implicit differentiation together in this case. So, yeah, this is something. And you'll get to the thought process of me answering this question. I mean, trying to get an idea of how to deal with this question here. All right, just as a typical A-level candidate, even
even
though I
though I
don't
don't
know
know
what
what
I
I
said
said
there.
there.
So a particular solution of this differential equation is such that y equals to 2 and x equal to 0. So the diagram shows a sketch of the graph of the solution this. The graph has stationary points at x equal to at A and B. One thing that is thinking around my mind as well is this differentiating. Um, just we know that divide x equal to 0, so I would just say that this equals to something there, right? It's not. Maybe most probably not. Because I really need to find out both values of y and x because I actually do not know the equation. Yeah. Okay, now I understand. Finally.
Finally.
So this is one thing that I'm going to use where dy dx equal to 0 as my as my companion. And on the other hand, for finding the y coordinate, I'm going to use my differential equation. So the first step would be to find the values of x. So what we get is something like this. So it means that when dy dx equal to 0, this thing gets away. 4 y cubed plus 1 cos square x equal to 0. So maybe I have to go for something like this. So basically this thing equal to 0. So this thing equal to 0 is one solution. This thing equal to 0 is another solution. So cos x equal to 0. And I know that when it is 0, at x equals to pi by 2 and 3 pi by 2. First, I think 3 marks from here. Second, we're going to go for these are the only solutions from 0 to 2 pi. Then we have 3y square dy by dx equals to 4 y cubed plus 1 cos square x. So we have here 3y square by y cubed plus 1 dy equals to 4 cos square x dx. So I've just basically taken this to the bottom. I took only this part because otherwise it will be a bit more difficult. And now I have to do something that I have absolutely against. I have to do two things here. First, I have to find out this thing here, which is basically, if you know the identity, 2 cos square x minus 1 equals to cos 2x, then it means that cos square x equals to half plus half cos 2x. So this means that this is exactly the same as 2 plus 2 cos 2x dx. Now integrate both sides. We're going to get here. If I differentiate this one, I'm going to get the top part. So I can easily say directly ln y cube plus 1 equals to 2x plus, um, I think it is going to be sine 2x plus c. And it says when x equal to 0, y equals to 2, which means ln 9 equals to, this thing is 0, so therefore ln y cube plus 1 equals to 2x plus sine 2x plus ln 9. So basically, y cube plus 1 equals to e to the power 2x times e to the power sine 2x times 9, e to the power ln 9. And I just put them separately together because I'm going to get something like this. E to the power 2x plus sine 2x plus ln 9. I know that if I add these different things together, I can separate them out by multiplying my different factors out there like this. E to the power 2x times e to the power sine 2x plus e to the power, no, minus e to the power ln 9. E to the power ln 9 is exactly the same as just 9. So that's why I wrote here 9. Then we have y equals to cube root of, same thing, 9 e to the power 2x plus sine 2x minus 1. So therefore what we have is when x equals to pi by 2, y equals to cube root of 9 e to the power pi plus sine pi minus 1. When x equals to 3 pi by 2, y equals to cube root of 9 cube root of 9 e to the power 3 pi plus sine 3 pi minus 1. Then we're going to get our solutions here. I just find it is my calculator, then we're going to get our answer. But I have to use my calculator because I have to keep my answer to one decimal place. Otherwise, I'm going to lose marks. So, yeah. I mean, at first it may seem a bit different for me to understand it abnormally, but what do we know? Because we have two variables in a single equation of single differential equation, it means that I have to do something with implicit differentiation. So I do that. I know the dy dx equal to 0. Then I'm going to get a relation right here like this. And then I can say that cos x equal to 0. And therefore these two. And then because I need to find out the y coordinate, I really do have to still overall integrate, solve this equation to get y in terms of x so that I can solve the equation. I mean, so that I can find out the value of y. So there you go.